Okay, looking at 8.4 notes, we are going to be talking about three different types of equations: linear, quadratic, and exponential, and determining which type we have depending on what they give us. So with this first one, they're giving us the equation. So it might be helpful to type it into your calculator. So now we know that we can graph all of these different types of equations in our calculator. So if I go to my y equals in my calculator and clear out anything that was already in there, I want to type in x plus 2. Now, if I graph this, I can see that it's a straight line, which means that I have a linear function. So for this one, I have a linear. Now, if they want me to fill out the table, I can go to second graph and I can fill out this table. So they have 1 filled out. At 1, it was 3. At 2, it was 4. At 3, it was 5. Then I go 6, 7, 8, 9, 10. So we can see that on our table, it's adding 1 every single time, all the way down our table. So whenever we have a linear function, it's going to be adding or subtracting on the y's every single time. So this is called the first difference, because it's the first time we looked at the difference between each number, it was exactly the same. So if you go to graph this on your graph down below, you can see it has that same thing and it has that linear shape. Okay, if we look at the next one, let's go back to our y equals, and we want to type in 0.5 parentheses 2, and we have to put our x in the exponent. So we haven't done this yet. If we hit this little caret button, it's a little arrow up looking button underneath your clear, that will take you to the exponents. And we want to put the x in the exponent. Yours actually on your calculator will make it a small x. Mine looks a little different. But if I go to graph this, it looks kind of like a J. It's a swooshing motion. We haven't really talked about this in the past. We've only dealt with a quadratic, which is the U shape, and the linear, which is a straight line. So by process of elimination, we can tell that this is an exponential. It's not a linear, it's not a quadratic, so we know that it's an exponential. So this one we will be talking about more in later chapters. But if we want to fill out our table, let's go to second graph and let's fill out our table. So on 1, they had 1, 2, they had 2, 3, they had 4, 4, they had 8, then 16, 32, 64, 128. So if we graph this first, we can see kind of that shape they gave us on our graph, where it's starting off very low and then it shoots up super fast. Now, if you notice on our table, it went from 1 to 2, 2 to 4, 4 to 8, and so this is multiplying by 2. So with exponentials, you're going to be either multiplying or dividing by a number each time on the y's. This is also the first difference. So if it's multiplying on that first time you're looking at the difference between the numbers, it would be an exponential. Okay, let's look at the next one. Let's graph y equals x squared minus 6x plus 9. So if I hit graph, I can see that I have that U shape. And we talked about that U shape is called a quadratic. This is what we learned in this chapter in Unit 8. Okay, so if we go to our table to fill this out, it looks like at 1 they had 4, 2 was 1, 3 was 0, 1, 4, 9, 16, 25. Okay, so if we look at this and we're looking, well, let's first graph it actually. At 1, they had 4, 2, 1, 0, or 3, 0, 4, 4, 1. This is super small. Okay, so it makes that U shape that we know as a quadratic. So just by the shape of our graphs, we can tell the different types. But also by this table, let's look. From 4 to 1, they subtracted 3. From 0 to 1, they subtracted 1. From 0 to 1, they added 1. From 1 to 3, they added 3. From 4 to 9, they added 5. So it's not doing a perfect addition or multiplication or subtraction or division. It's doing different numbers each time. So 9 to 16, it's adding 7. And from 16 to 25, it's adding 9. So on our first differences, it was different numbers each time. So what I'm going to do is I'm going to look at the second difference. So I'm going to look at what was changing between each of these numbers. So from -3 to -1, I can add 2. From -1 to +1, I can add 2. From 1 to 3, I can add 2. From 3 to 5, I can add 2. From 5 to 7, I can add 2. And 7 to 9, I can add 2. So on that second difference, we can see that it was the same thing. So whenever you're looking for a quadratic, the second difference has to be the same number. Okay, so let's look at some tables. If they just give us the table, they don't tell us anything else. So I always like to look at the y's. So on this one, I always start off by looking for if it's adding or subtracting anything. So I can see from 10 to 13, they added 3. From 13 to 16, they added 3. 16 to 19, they added 3. 19 to 22, they added 3. So since it was adding the same number on the first time I looked at the differences, that means that this is a linear function. Okay, let's look at the next one. I'm looking for a pattern. So these numbers are getting big very quickly, which means it's probably multiplying by something. So to get from 4 to 12, from 12 to 36, I can see that it's multiplying by 3 each time. So that means that whenever it's multiplying, we have an exponential function. So with linear, we're either adding or subtracting on the first difference. If we are on exponential, we're multiplying or dividing on the first difference. And then on this next one, it's going from 3 to 0. From 0 to -1. It doesn't look like it's doing the same thing every time. So on the first time, from 3 to 0, it subtracted 3. From 0 to 1, from 0 to -1, it subtracted 1. From -1 to 0, it added 1. And from 0 to 3, it added 3. So it wasn't doing the same thing each time. But if we look at the second difference, from -3 to -1, I'm running out of space, it adds 2. From -1 to +1, it adds 2. from 1 to 3, it also adds 2. So what you're looking for on this one, we know this is a quadratic. So with quadratics, you want it to add or subtract on the second difference. So the second time you look at the differences between the numbers, if it's adding or subtracting the same thing, that means it's a quadratic. Okay, last one, we're gonna be just graphing some points. So we wanna graph each of these and kind of look at the shape of what's happening. So with -3, 2, -2, 4, -4, 4, -1, 8, and -5, 8. When I connect my dots, I can see that I have that U shape, which I know is a quadratic. So that U shape is what we're looking for with a quadratic. Okay, let's graph the next one. -3, +1, -2, +2, -1, 4, 0, 8. And then if I were to graph this next one, it's going to be off my graph. It would be 2, 14. It would be super high up there. So it at first kind of looked like a linear, but when I connect these, they're shooting up super quickly, which is kind of like a J shape, which means we have an exponential. So that swoosh. And if it was linear, we didn't have that, but that should be just a line, a straight line. Okay, so always look at the shape that the graph is making when you are just given points.